Uh, Hello everyone, welcome to this class. We shall be discussing about principles of AC generation. As you can see, this curve is going to give us a number of terms that we have defined already in these notes. The first term that we're going to look at is the maximum value. The maximum value is the distance from the horizontal to the highest point reached in that particular curve. So we will start from the first point. We define what a waveform is. A waveform is the curve obtained by plotting the instantaneous values of an alternating quantity such as voltage and current along the y-axis and the time along the x-axis. A waveform of the type shown above is called a sine wave. It can also be referred to as a sinusoidal wave. So this curve takes the shape of a sine wave. That is why it is called sinusoidal. It's called a sinusoidal wave. Sinusoidal, the first part represents a sine wave. So we are going to look at a number of terms. The first one would be peak to peak. Peak to peak means from the minimum point to the maximum point, the distance from the minimum point to the maximum point. When we talk about the maximum value or the peak value or the amplitude, remember the distance from this 0 to this particular point, this point x, will be called the peak value. Or if you like it, you can call it the amplitude or the peak or the maximum value. So we have three words. This distance can be called the maximum value, it can be called the peak value, it can also be referred to as the amplitude. The amplitude. We will be defining them as we move on. Another thing that you need to know is a cycle. A cycle is a complete wave. Remember, a complete wave has got two cycles, the positive cycle and the negative cycle. Two half cycles. If you take this half and this half, it forms a circle. That is what we are actually calling a cycle. So a cycle is a complete wave. Another term that we actually want to define is the periodic time. The periodic time is the time that is taken to complete this one cycle. So if this wave was to start from this particular point 0, the time it will take to reach this point is what we are calling the periodic time. That periodic time is also given in seconds, just like any other time. Another important point we will be defining is the frequency. Frequency is the number of cycles completed in 1 second. So the number of vibrations, the number of cycles a wave will undergo in 1 second, that is what we call frequency, so that we can go through them one after the other. And remember, we have said peak to peak is the distance from the minimum point of that wave to the maximum point of that wave. Peak value, this is the peak. From this particular point to this point is what we are calling the peak. So if you add another one to this particular point, that one, this is another peak below the x-axis, this is another peak above the x-axis. So the total will be called peak to peak, maximum to minimum. So we can start from number 2. A cycle is one complete repetition of the sine wave. So if this wave starts repeating, so it means it has undergone a full cycle. Number 3, we look at the periodic time. Periodic time, like I said, it is the time taken by an alternating quantity to complete one cycle. Frequency is the number of cycles completed in 1 second. Like if you had a pendulum swinging, the number of swings it will take in 1 second is what we are calling frequency. How fast it moves. Mathematically, frequency is taken as the reciprocal of time. Frequency is the reciprocal of time. That is why we have said frequency is equal to 1 over time. Or if you like, you make time the subject of the formula, time will be equal to 1 over f. Remember, this time is what we are calling the period. So period is also called time. And one thing that you also need to remember, the SI unit of frequency is measured in hertz. which is denoted as Hz. So those are the SI unit of frequency. We now take the first example. Which reads an alternating current completes 5 cycles in 8 milliseconds. What is its frequency? Remember, you need to convert this time into seconds because it's expressed in milliseconds. You know, you divide by 1,000 to get it in seconds. That is why I've divided it by 1,000. Dividing it by 1,000 is the same as writing 8 times 10 power negative 3. And remember what I've said, frequency is the number of cycles completed in 1 second. So the question tells us it took this wave 8 milliseconds to complete 5 cycles. So for us to get frequency, we must ascertain the number of cycles that were completed in 1 second only, because these cycles were completed in this time. So we need to ask ourselves, how many cycles will be completed if we are to take only 1 second? That is why I've said this particular time completes 5 cycles. What about 1 second? So if you multiply, you will get this. So this is the frequency. Or these are the number of cycles. In fact, you can write it cycles per second. Another SI unit of frequency is cycles per second. The number of cycles per second. So it means in 1 second, it will take 625 cycles to complete that particular 1 second. So that is the answer to this particular question. We move to the next term that we are defining. So I was saying we are moving to the next term, which is amplitude. Amplitude, like I said, is the distance from the x-axis to the maximum point in that half cycle. So it is the largest value reached in a half cycle, or it is the distance between the horizontal axis and the peak or the maximum or the minimum point of that particular wave. That I had explained earlier on from the waveform. The next one is peak to peak value, is the difference between the maximum and the minimum value in a cycle. That one I've already explained, and it is well captured in the waveform. The next point is the average or the mean value. Remember, whenever you are getting the mean, you take the area under the curve. Remember, we have drawn the waveform on the other side. If you want to get the mean, you will take the area under the curve over the length of the base. This is the same as you will take the maximum value against the point you are able to see on the x-axis. Remember, if this is our waveform, if that is our waveform, if you want to get the maximum point, if you want to get the mean or the average, we have said you will take the maximum. Remember, this is the maximum point, and this particular point is 90. So you take the corresponding point of the maximum on the x-axis. So that is why we are saying if you want to get the average, it is the same as you take the maximum value, which is this one, the same as the amplitude, divided by the corresponding point on the x-axis, which is pi over 2. Mathematically, if you analyze this, it becomes 2 over pi times that particular value. We are moving on to the 8th term. We are defining the root mean square value, which is denoted by RMS value. This is the effective value of an alternating current which will produce the same heating effect as an equivalent direct DC current. So we are trying to look at the value that we can be able to get from an alternating current compared to a DC. So that is how you define the root mean square, the effective value of an alternating current which will produce the same heating effect as an equivalent DC, that is direct into brackets DC current. For example, the domestic main supply in Kenya is 240. We know a single phase power line has got 240 volts. and is assumed to mean that we take it like the 240 are in RMS value. That is the root mean square value. The 240 is the root mean square value always. Whenever you are given a single phase which is 240, just automatically it means that that is the root mean square value. So how do we get the root mean square value? The root mean square value is taken by the maximum value, you divide by root 2. Another point we need to know is the form factor. The form factor is the ratio between the RMS value over the average value. Remember, the average value is also called the mean value. And if you look at this one, the RMS value, remember the RMS value is this, and the mean value we are done it is taken as, remember, the RMS value is the same as maximum value all over root 2. And then we know the average. The average is equals to maximum value divided by pi over 2. So if you divide the two, you will realize you will be having something like maximum value all over root 2 times pi over 2 divided by, if you divide by maximum value all over pi over 2, remember this one becomes maximum value all over root 2 times, you invert, that will be pi over 2 divided by maximum value. So these and these will cancel, so that you remain with pi over 2 divided by root 2. This is pi over 2 divided by root 2. Remember, this is the same as pi over 2 root 2. If you divide this, you will get 1.11. And that is why we are saying the form factor is 1.11. The peak factor is given by the maximum value divided by the RMS value. So if you take the maximum value, which we have said is given by this one, you divide it by the RMS value, which is actually the same as taking the reciprocal. You will get 1.41 as the value. So we are looking into an example. The example reads, determine the peak and mean values for a 240 volt main supply. Like I told you earlier, this main supply in Kenya is given in terms of the root mean square value. So meaning the voltage in root mean square value is equals to 240 volts. That is what we have. They are asking us to get the peak value. Remember, the peak value is the same as the amplitude, is the same as the maximum value. And we know the root mean square value is given by maximum value divided by root 2. And remember, this is the same as peak. This is the same as peak value. So if you want to get the peak value, that automatically tells you to get peak value will be equal to root 2 multiplied by the RMS value. So what we do, you will take root 2 multiplied by the RMS value, which is 240. If you multiply that one, you will get 399.41 volts as the peak value. So we have answered question 1. Question 2 requires us to get the mean. Remember, the mean is the same as average. and we said the average is given by maximum value divided by pi over 2. That is how you get the mean. And remember, that is the same as writing 2 over pi times the maximum value. Times the maximum value. So if we go by that formula, then it means the mean value will be equal to 2 over pi multiplied by the maximum value or the peak value. Remember, the maximum value is the same as the peak value. This is the peak value, or you can call it the maximum value. So what we do, you multiply by this 399.41. If you multiply by this, you will get 216.08 volts as the mean or the average value. So that is how you sort out that question. So we will stop there.